Yes, welcome here to another second episode of Internet of Things. My name is Patrick Opio Okiror. I'm going to be taking you through designing of a simple prototype for an I.O.T. It can consist of user interface such as a smartphone, maybe web front end, hardware device, back end, and maybe connectivity. This is what we are going to learn now. So just kindly subscribe and get started. Now, the user interface is what the users will see. This actually comes with the form of a web front end or a smartphone app. For example, you can have a user interface. Yeah, this is a user interface. This is like a person or a user for an I.O.T. because we said it consists of a user interface like smartphone app or web front end, a hardware device, back end software that implements the business logic, and maybe connectivity. So basically uh, four kind of applications which are here in designing of an I.O.T. So this is basically what we see, that a user interface. Maybe we have the hardware device. This is the hardware, something like the device. This is hardware device. This is user interface. Then we have the back end software. Back end software. For example, just something like a software. Yeah. Then we have the connectivity. This one is can be like wireless, Wi-Fi networks, yeah, and so on. So that is basically the four basic things for designing of an I.O.T. Because the user interface is the first thing that people will see when they look at your product. Yeah, it pays off to make maybe this looks good, first impressions, and so on. So our four I.O.T prototypes, the user interface should do should do things, uh, prove the value of the system to the user, allow users to interact with and maybe explore the system. Now, when we talk about the user interface, this is basically the primary purpose of the user interface in the context of I.O.T prototyping is to prove the value to the user. For example, it is just one of the key killer features of the I.O.T, the ability to compute and display customer maybe value in real time. For example, for the user interface, it is the first impression for the user. For example, you can have here we have the username. This is what you enter. Then we have the password here. This is where you can put the password. This one you can make it, you can check and uncheck at the same time. So we have here now, these are options, either maybe login and reset password. So basically the user interface, if this one is designed with a nice kind of colors and so on, it enables the user to basically log in with even when the colors are matching and can be liked by the user. Now, another importance of a user interface is allowing users to interact, yeah, with the with and explore the system. This one is very important because the secondary purpose of the user interface is to allow users to interact with the system. Yeah, it may sound strange that a user interaction is merely the secondary purpose and not the primary, but this is this is because we are building a prototype and not the final product. There's a difference between a final product is the one which is already complete, and for example, if it is a web-based system, you can be hosted. Yeah, and the purposes are slightly different. The prototype is meant to validate the business, which is similar, but some maybe the goal from the final system is to bring value to the customer. uh, Now basically in the user interface, the user should be able to see the data generated by the system, yeah, and dig down into it. This allows us as the product owner to study what the users feel is important, as it may be something different from what we initially thought. That's the second advantage of the user interface as to why we design them. Now the second component of a prototype in an IoT is we go now. The next one is the hardware. Yeah, is the hardware. Now the hardware is divided into, there are different types of hardware. For the case of Internet of Things, the hardware device is the part of our prototype that most people think about when thinking maybe IoT, but this is only one piece of the puzzle. Yeah, we need the hardware device to reach out into the maybe physical world. The hardware device includes one or more like sensors. You see, we have like sensors. Yeah, we have sensors that measure something in it physical environment. Yeah, and they affect something in that same environment. In addition to the sensor, actually we have another one called the actuator. Yeah, these two, yeah, these are part of the hardware in designing an IoT prototype. So in addition to the sensor, the hardware needs some way maybe to communicate, usually through a wireless connection. This is what we said last time as connectivity. Connectivity, this one you can mean wireless. Maybe you can have your Wi-Fi somewhere, maybe some things, maybe any connection which can be which can suit you for the completion. Yeah, but the technical requirements are not the only requirements. The hardware also needs to look reasonably good in the hands of anyone using it. So while we cannot expect to see Apple style hardware at this stage of the process, we can maybe leverage the latest developments in for example, we have 3D printing. For the case of this, they can print something in the 3 dimension. Yeah, let me draw something here. For example, this first interface, this second interface, and maybe this side interface, printing something which looks like real. Yeah, 3D printing, that's the latest kind of technology. The designers have reached. Yeah, now the back end, this is now the third component which we talked about. The third one is said, well, the back end. The back end software is where the intelligence of the system resides. Yeah, the back end part of an IoT prototype is often overlooked because it's not visible to the users. Yeah, and the customers, like the user interface, and it does not have any physical presence like the hardware device, but it is in the back end that the real magic happens. This is where the business logic is encoded. So the back end both collects data in its database but also makes decisions on actions. For example, now I want to give you some example. Yeah, Now an example of the back end. This is now the third component of what? Of prototype design of I.O.T. So we have the back end. An example here, an example can be, take a look at the hot disk usage tracking system. Yeah, an example, let's have the hot disk usage tracking tracking system. Now here, the hot disk usage tracking system consists of a bunch of sensors. Now what does it consist? It has sensors. Consists of sensors that are attached to disks and they collect the data, and that computes the statistics, maybe for example, that are shown in the user interface. Without the back end, the system would not be actually able to do its job. The back end actually runs in what? It runs in either cloud. It runs in cloud and others. Now when we talk about the connectivity is what connects the hardware with the back end and the back end with the user interface. This is connecting based on the wireless connections we talked about last time. Yeah, the connectivity is often split in two parts: the user back end connectivity and the device back end connectivity. User back end connectivity is almost always done with maybe the usual internet protocols, IPs, often with the maybe REST APIs for the device back end. Yeah, connectivity, there are several maybe technological options. We are going to look at this now. Now, when we talk about connectivity, this is the fourth. Oh, what's happening with the camera? Okay, connectivity. It has like three. There are several technology options here. One, we have the connectivity with the IP version 6 meshing. This one is also sometimes called 6LoWPAN. Actually, it is not that it's called 6LoWPAN, but it takes this 6LoWPAN and the thread is part of it. It can help to run on it, or Wi-Fi. This is wireless fidelity. Then two, we have the connectivity through users. Yeah, users smartphones. For example, this one can use Bluetooth for connecting. As we said earlier on here, we connect with the IPs, can use these like threads and 6LoWPAN for, or wireless for connecting. This is like connect. If you say connecting with the IP version 6 here, what does it maybe you use for connecting? Uses the thread or Wi-Fi. Then the third we have the connectivity through a hub. Yeah, a hub is a hardware network device. For example, this one can use like maybe ZigBee and others. Then the four, we have the low power wide area networks. These ones, they can abbreviate it as LPWAN. Low power wide area networks. Yeah, this technologies can have like the Sigfox, maybe things like LoRa and so on. Yeah, this is basically a connectivity in wide area networks. Now, we basically use the IP version 6 meshing because of the flexibility it offers in terms of different ways to connect to the internet, the low complexity of the access points because it does not rely on any third party infrastructure, and because it allows for very large wireless networks in each installation, yeah, while achieving a very long lifetime on batteries. Connectivity with Wi-Fi on each device provides a similar flexibility but does not have a very long range. Connectivity through the user's smartphones is useful also, yeah, for specific applications such as fitness trackers, but is not suitable for larger scale installations or remote users. Yeah, it is through a hub, as we talked about last time. Can be seen a combination of the direct connectivity with the Wi-Fi or IP version 6, yeah, meshing, but does not provide the same flexibility in terms of maybe connectivity to the back end. Now, with the low power wide area networks, um, technology have a very good range but can only support data rates on the order of a new maybe few bytes per day, and often rely on third-party infrastructure, sorry for the slip of the tongue, to operate, which may have maybe spotty coverage or not. Yeah. Now, for prototyping, basically the last remarks for this session, episode 2. For prototyping, the choice of connectivity mechanism, yeah, is not only it's not always crucial because the purpose of the prototype is to validate the business through the target users, and this can often be achieved through many different connectivity variants. But in some cases, yeah, the business depends on a specific type of connectivity which which can be available, such as remote or very large scale deployments. Now, in such cases, connectivity must be well through from the start, well be thought from the start. Now, as we conclude, now in conclusion, about prototyping, here we say every successful I.O.T based product system or service needs to be prototyped. Now we can say maybe these are maybe what can I say, maybe what an I.O.T can consist. One, needs to be prototyped. In this one it can help to validate the business. Yeah, validate the business. Yeah, it can help to validate the business and technology choices. Yeah. These articles look at the 4 different parts of an I.O.T prototype. Now, the 4 parts, we talked about them, of I.O.T prototype. Now, these 4 types include: 1, we said earlier on that, user interface, where the users can be interacting here. The user interface, the hardware, the back end, and the connectivity. Yeah, but because the purpose of the prototype is to validate the business, some of the decisions along the way are different than maybe what they are for the final product. For example, the primary purpose of the user interface is not to let the user interact with the system. Okay, importance of user interface. Here we say the purpose of the user interface is not to let the user interact with the system, yeah, but to prove the value to the customer. This must be taken into account then designing and building the prototype. Yeah. Yeah. Now, when building an IoT prototype, yeah, there is no need to go too far. The hardware and connectivity rabbit holes, not until after the prototype has proved the business case. Therefore, maybe it helps companies quickly prototype their IoT products. And yeah, basically that. Okay, thank you for watching. This is the end of the lesson for the case of designing a prototype. What we have seen what we need in order to design the best prototype for an IoT. We said user interface, we have the back end, we have the hardware. Which ones do you want to specify? Then which networks do you need in order to connect? So yeah, basically this is what I had for you, and see you next time. Please don't forget to subscribe. We have other things coming. And coming. Thank you. Subscribe to this channel. Yeah, and the channel name, I think everyone is aware about that, and just clicking, and don't forget to turn the bell icon. Thank you. See you.